Welcome to the Making Data Simple podcast, or Making Everything Simple podcast. Al Martin here, your host, and I am a host with a cold today. And we don't always release the podcast episodes in order. So if you heard me, I think in a previous podcast that had a cold, it's not like I have two colds, it's just the same one. So either that gives me the radio voice, finally, the radio voice that I've always wanted, or it just makes me sound like I have a cold. What do you think, John? Radio voice or just cold?
Sounds pretty fantastic to me.
Ah, the perfect guess answer. Love it. Love this guy. Lying, but that's great. I am, as you've now heard, I am with the distinguished John DeNero. He is a professor at UC Berkeley, a chief scientist at Lilt.com. That's Lilt.com. He has a PhD in computer science from Berkeley, a ton of other degrees. He's got an undergrad and master's degree from Stanford, including an MA in philosophy. Dude, I'm feeling like bad about myself now.
Well, some people are afraid to go out in the world, so they just stay in school forever. I'm one of those.
Oh, I doubt that's the case. But then you've also, I'm not even finished yet, man. So hold on. You've won a Campus Distinguished Teaching Award in 2018. Again, I could go on and on. I guess I'll stop there, but I feel like I'm not getting it done. Fat, drunk, and stupid is not a way to go through life, I guess. Welcome, John. I appreciate you being here. You're a distinguished guest. No kidding. So, again, one more time, a specialty in artificial intelligence, chief scientist at Lilt Incorporated, which, to my understanding, develops and operates an online transaction platform. I'm going to stop there. I'm going to let you introduce yourself, and I've got a lot to talk to you about.
Sure. Thanks so much for having me on. This is great. A little bit about myself. I started studying artificial intelligence in grad school, focusing on language, and in particular on how to automatically translate one language to another. And there was one spot on the world that was doing a whole lot of that, Google. So I went and joined Google Translate after I finished my PhD to work on that system. But at the same time, like everything that was happening in artificial intelligence, computer science education, data science seemed pretty interesting to me more broadly. And there were a lot of students wanting to study that. And so I decided to leave industry and come back to primarily teach at UC Berkeley because it was kind of the right moment for computer science and data science education to figure itself out, figure out how to scale up so that we could teach lots of students this stuff. And figure out what to tell them to prepare them for the world that's coming up. So that's sort of my background. And then, as Al mentioned, I'm also chief scientist at Lilt. So Lilt is a startup about machine translation, kind of stuff that Google Translate does, except for a little bit different. Instead of doing things fully automatically, we keep people in the process. And that means we can actually get the translations right at the end of the day instead of only kind of right. So we're doing a human-computer interaction artificial intelligence platform so that we can really get the translations right at the end of the day, but we can make the translations the translators kind of be more productive, more accurate, and get more done.
Wow, a lot to talk about. So look, I'll give it to your preference. Should we dive into Berkeley? Because I got a lot of questions there first. Or should we go to Lilt and talk about some of the machine translation you talked about? What do you think?
Well, I'm sitting here in the middle of Berkeley campus, so maybe we should talk about that first.
All right. Well, that answers your location, first of all, right off the bat. Where are you originally from?
I'm originally from Pasadena, but I grew up mostly in Minneapolis, which is a little bit colder than Pasadena. So then when I had a say in the matter, I came back to California.
So, yeah, because you're just trying to get away from the cold or what?
Well, California's a nice place.
Very good. All right. So sounds good. So you teach. Here's what I found. You teach the now famous undergrad artificial intelligence course at Berkeley, for which you won a campus-wide teaching award, and I got to believe that you're extremely proud of that. So again, lots of questions, but let's just start out with very simply, what's the material? How is it organized? And then I want to go into that teaching award in terms of where that went. But material and how it's organized. Let's start there first.
Yeah, so when I came to Berkeley as a graduate student, 15 years ago, we had one undergraduate artificial intelligence course. And I taught that, and it was an upper division, advanced course that was all about how to make computers make decisions on their own. So fully automated, This was about, robotic decision-making and control, Bayes nets for making diagnostic decisions in medical applications. So it's kind of all about that kind of core artificial intelligence that had been, successful sometimes and not successful sometimes through the 80s and 90s. And we'd built a course around that. Now we have a whole array of courses, and I've helped build some of those. So after teaching that artificial intelligence course that was kind of advanced undergraduate, all about making automated decisions, we recently developed a new freshman course called Foundations of Data Science, which is also an artificial intelligence course in the sense that we teach students, even in their freshman year, how to make predictions, how to build classifiers, how to use data and computing together in order to get something done. But it's got a different orientation. Instead of being about fully automated systems, it's about how to use data to make decisions where you're letting the computer do a lot of the work for you. So it's doing the optimization procedures, it's fitting the regression lines, but it's up to the person to figure out how to interpret that in order to understand the world. So maybe I'll talk a little bit about this freshman course since it's a little bit newer. Foundations of Data Science is a replacement for statistics. A lot of students don't take intro statistics anymore. Instead, they take this course where they learn to program first, and then they learn how to think about uncertainty in the world and how to interpret. You don't always get to look at all the data. You get to only look at a sample of the data. What can you actually say about the world based on that? So that core idea of inference about the world based on uncertain information is one of the big topics. The second big topic is how to manipulate data sets. So if you have a few different tables that tell you, here's the weather and here's people's car rentals, how do you figure out whether people drive more slowly in the rain? Well, you have to join those tables together. So that kind of manipulation is core, I think, to getting something done in the world. And then the third part's about prediction. So if you have the text of a movie script, can you tell if it's a horror film or a comedy or something like that? And we do all that in a semester-long freshman course.
So I think I made a miss. You talked about the replacement for statistics, manipulating data sets and predictions. But did I get that right? The three? Or the first one did I mess up?
Yeah, so what is statistics all about? It's really about what can you infer about the world given that you only see some data. And that's exactly what we try to teach, except for instead of doing stuff by hand or memorizing formulas, we use computers to do all that. So we load real data sets from the web and manipulate them. And then to do the inference, to compute a confidence interval or a hypothesis test, we use computer simulation techniques, which are very common in the real world statistics. When statistics professors do consulting, they're often using simulation-based techniques in order to draw inferences. But what we used to teach in our statistics courses was the more classical view where you'd make an assumption about the data that sometimes wasn't true about a normal distribution, and then you'd have to work out with some formulas, what the confidence interval was. And so we've switched to instead doing a more computational view of how to make inferences about the world. That's right.
See, John, before the podcast, we were talking about how long does this usually go? And this is why I say it's take a full hour, because I could talk to you all day about every one of these topics, but I'm going to try to figure out how to pinpoint and do the questioning right to get to so I don't take you, it'll be respective of your day. So, when I was in school, I took statistics, and I think it was mostly about card tricks. But now you're saying that, do you need statistics anymore? Is this really truly a replacement for statistics? Because it's taken it to a new level. You still get statistics in the program itself, but it's about data. It's about making decisions upon that data, etc. I guess the question stands: do you still need statistics, or do you skip that altogether with a course like this?
Oh, that's a great question. So, we built the course in collaboration with the statistics department with a bunch of statisticians. So do we need statistics? Absolutely. I think what is changed is the way in which you learn about statistics can evolve now that we have computers around. Most statistics courses that were designed for undergraduates assumed that computers didn't exist and all you had was a hand calculator. But that's not true. You do have computers. We can learn how to program them pretty quickly. And that means we can take different approaches. So really what we're trying to do is just align how we teach statistics to undergrads to how real world statisticians actually practice their discipline these days, which is very computational. So this is just like a more like making sure that undergrads know the computational view of what statistics is, rather than throwing out statistics altogether.
Now, listen. I'm sure the statistics department didn't listen to this podcast. So let me ask again. Do you really need statistics now that we got your class?
Oh, yeah, no, I like it. I like it. You're giving me a hard time. Yes, we do. I think we really need. I think more than ever, we're at a stage in the world where people are trying to make decisions based on data, as opposed to just on their intuition or anecdotal evidence. And that's a good thing. But there are lots and lots of ways to come to the wrong conclusion from a data set. And so statistics is really about making the right conclusions or sound conclusions from data, as opposed to being misled. And that, I think, is more important than ever. So this is the age of statistics rather than something we don't need anymore.
I know when I took statistics, it was a prereq for everything else, from differential equations and everything else. I thought, I got to take statistics. Now it's like the center of the universe. It feels like, in terms of where we're going with this stuff. Let's talk about manipulating data sets. The interesting thing here is, for me, like the beginning of this year, I took over what I call Watson Tools and Runtime, which essentially are our machine learning. It's our machine learning play here at IBM, and I've learned a lot. And since then, data. I used to be a data guy. I'm still a data guy, but my view on data has changed a little bit, and this is where I want to get your view on it. In that, I think it's important to understand the strengths and limitations of the data set that you're looking at. Because what I find now is I'm dealing with clients, there's a lot of data sets out there, and those data sets have been out here for years, perhaps. I mean, years upon years, which is great. You got a lot of information, but it's really not intended maybe to the questions that you're looking to answer. So I guess what I'm trying to say is the historical data was collected unrelated to the business problem that we're currently after. And I'm also finding, to take that a bit further, is the part of data understanding also includes the costs and benefits of the data source. Sometimes you got to go pay for some data to complement the data that you already have. I guess where I'm going with all this is, where does data come into play with the course? Because it's taken on new meaning. So what do you think about all that? I mean, where does data play, and how do you go about getting the right data for the right question that you're trying to answer?
Oh yeah, such a great topic. I think, well, let me step back and say there has been another shift in statistics where people used to think really hard about designing studies of how to collect data in the first place. And they still do that, because there are still settings where you get to go design your own experiment and collect data from scratch. And this happens all the time in the sciences, and it's a wonderful thing. But when you switch to business applications, a lot of times you're working with found data, or data that already existed. It was collected for a completely different reason than what you're trying to use it for. And that's a different game, right? That means you don't get to design the study. Instead, you get to work with the information that you have available. And that introduces a whole host of new problems. Do these data really describe what you care about? Is there a systematic difference between the distribution that was happening when this data was collected and the future that you're trying to model? All of that is what makes data science really interesting these days, but it's really hard. So what do we do in our courses about this? Well, we actually have whole units. So in this freshman course, now we have like a junior level course that adds on to it, the principles and techniques of data science. And in both of these courses, we find real world data sets that are out there on the web already, and we try to repurpose them. And we try to do it in a way that's careful, that actually teaches students that if you don't clean it up and you don't visualize the data beforehand to see what's missing, and you don't make good assumptions about how to fill in the stuff that's missing, then you can come to entirely the wrong conclusion. So so paying deep attention to the data, kind of working with the data, visualizing the data, trying to understand what you have available, reading about where it came from. This is all just essential to the process of building anything these days that's a data-driven system, because the data just as important as the code. If you don't have both, then you can't build an artificial intelligence system.
But I got to believe the students want to skip to the code, no? Or do they find interest in that data? Have you found a way to say, hey, look, now this is just as fun as is getting, starting our coding, assembling the right data, and it's kind of like an art. But I got to believe the students, are they more interested in just getting to the code? I mean, we always talk about here that, 80%, and this is another question, I know I'm throwing a lot here, but 80% of the time is spent on gathering, cleansing, um, nurturing, whatever you want to call it, the data, versus 20% is actually on the coding and doing the magic in the models or whatever the case may be. Do you find that to be the case?
I do wish I had a secret recipe for making data cleaning fun and engaging, but it turns out that that's always going to be the less glamorous part. But I think in a course setting, we can do the following. We can show that if you just blindly apply learning techniques, you can build systems that don't work. You might even think that they work, but they don't work. And then we can show them that they don't work. And that the real problem was they didn't spend enough time on data cleaning or data representation. So that's a lesson that you could learn the hard way out there in the world, but it could be very expensive. Instead, if you just learn it while you're in school, then you can appreciate that there's value in doing all that data cleaning and data collection work, even if it's not the coolest part, because you really do want the system to work at the end of the day. And if that's your goal, then you have to pay attention to that in addition to the algorithms.
You think it's about 80%? Is that what you usually find you're spending your time on?
Well, yeah, I guess in my life, like my industry engagement,
Yeah, yeah.
I've always been lucky enough to work in teams where I don't have to do all the data cleaning myself. So I'd say like team wide, yeah, it's always 80%.
Farm that out.
But sometimes I get to work on the algorithm side, and that's pretty fun.
Yeah. So speaking of their algorithm side, well, let me back up. I mean, when you say, or at least when I'm looking at your teaching artificial intelligence there at Berkeley, it is, I guess I would ask you to help me with this. We overuse the term artificial intelligence at IBM. Here we call it mostly augmented intelligence, but it's really ML. It's a practice of data science. I mean, help me characterize that in terms of what you're teaching? I mean, it sounds like you have elements of everything, but how would you describe it?
Yeah, we've decided to call it data science, the most broad version. That's about careful data collection, data cleaning, this whole life cycle of doing exploratory data analysis. Maybe that means you need to do more cleaning. Now it's time to build a model, make some predictions, do an evaluation, assess that that's right. So yeah, we call that data science around here. And that includes artificial intelligence, some inferential statistics, just understanding the domain of the data that you're collecting. So this is something that all the different departments on campus can participate in because only the folks in public health really understand the public health data and what it represents. So that sort of umbrella of the whole domain we call data science. And that, I think, is something that has many different paths through it, of course. And this is a big campus. I have 30,000 undergrads. They're not all going to study the same thing. So we try to give them all the same foundation, the same skills about manipulating data, about making predictions, about making inferences, but then they can figure out exactly how they want to specialize. Do they want to go deep into like robotic control, artificial intelligence? Do they want to go more into an applied area of making inferences about particular data, climate change or something like that? And that all could seem like data science to me.
What degree are students usually going after when they start taking many of these classes? I know it sounds like a silly question, but I was at a university recently. I was talking about data science with them, and I said, where are these classes? And they said, oh, they're in the business school, which shocked me. I was like, they're on the business side. I was on the engineering, because I went through engineering. I thought, well, that seems like more, and I had to take statistics and everything through engineering. Where does that fit in at Berkeley? Help me out here.
Yeah, great question. So most of what I've described is collaboration between the two departments, the statistics department and then where I sit, which is electrical engineering and computer science.
Oh, my favorite.
So that's kind of our core, though there are folks from all over campus that have contributed to these courses, decided to build elective courses, from economics, from business, from operations research and industrial engineering. We have a school of information. But then, yeah, much more broadly, like I said, folks from public health, folks from linguistics, basically all over campus have said that they're working with data in their domain and they want to collaborate with us. So it's very broad, but the kind of central core of these new courses were built as a collaboration between statistics and computer science. Now, you also asked, what do students major in? And that's an interesting question. So the biggest major on campus is computer science. The second biggest major on campus is electrical engineering and computer science, which is mostly just more computer science. If you ask the students in there, most of them are focused on computer science, but they're getting a little bit more of the hardware side as well. And neither of those were designed around data science. Those majors were designed around building applications. And so now we've built a new major. And we just had our first graduating class a week ago. The data science major at Berkeley is the kind of thing that a lot of universities are thinking about building, an undergraduate major in data science. We developed it over the last few years, and we just had our first graduating class. And we've already had 110 students graduate in the program. So it's already not one of the biggest majors on campus, but already sizable. And I'd expect it to be growing fast. So what's the difference? Like if you study computer science, I think mostly you're using computers in order to build applications. If you're studying data science, well, there's still a computational element, but you're really trying to understand something about the world and about making decisions. That's sort of the focus. So data science major gets a little bit more breadth about understanding domains where you would apply this, understanding more of the statistics, whereas computer science tends to focus more on just the computer science department.
So, man, I got a lot of questions for you, man. So I got it. So, but you're primarily, you consider yourself in the computer science space.
Yeah,
yes?
yeah. I mean, that's who pays my paycheck, and it's nice around here that people get to wander around and work together however they feel like. But there's some organizational structure in a university, and I sit in computer science. I teach a lot of computer science courses in addition to the data science stuff I've been talking about.
So, but one thing that caught my ear is when you were talking about electrical engineering. Obviously, that's what I went through, or not obviously, but that's what I went through. But you say it's really integrated with computer science. So what are they taking out? Because, whether it's electromagnetics, differential equations, physics 1, 2, 3 that I had to take, what are they removing and replacing with computer science?
Yeah, good question. So we have one department for electrical engineering and computer science. This is historical, but we also like it this way because it turns out there's so much work at the intersection, especially with our junior faculty who have come in recently. So many are doing kind of robotics or imaging, stuff with sensors and computation together. And so it's just really natural to have them together in one department. But what about the undergrads? Well, basically, they take basics in both sides. They take the electrical engineering core and the computer science core. And then they get to pick what electives they take. And so if they never want to learn the advanced signal processing or the advanced electronics, they can just skip that and study algorithms and artificial intelligence instead. So it's really flexible degree that makes sure students have kind of foundational knowledge and a little bit about circuits and a little bit about all the math you described, and also the fundamentals of programming. Yeah.
They're not going to get out of differential equations then.
That's a tricky one. No, they still have to do that.
All right, good, because they should. I had to get through that and everything else just as well. So, but you say, so the bottom line is that the thought is that they can pick a focus area. In other words, I presume is that they're getting to junior, senior. They can take more advanced classes in algorithms, et cetera, or they could take more advanced classes in I don't remember what you said.
Sure, yeah, like the electrical engineering side of like electronics or signals and systems or circuits or whatever. Yeah, and as you might imagine, most students these days are focusing on the computer science side, but it's nice for them to get to choose. And the freshman and sophomore courses that we have them all go through they're pretty darn rigorous around here. So they have to know something about everything before they get to really choose their electives. And that I think is good because then they can make an informed decision about what they really want to study. Some people come in and they think all they want to do is computer graphics, and some of those people do computer graphics and they love it and they go work for Pixar. But some of them discover something new while they're around in the intro courses, and that's a good thing. Then they can go study that other topic that they didn't even know existed.
So look, I'm a fan of electrical engineering, obviously, because I went through it. But I got to believe that the ton of opportunity given in the computer science area. So to your point, I got to believe a lot of students are heading in that direction because of the opportunities out there, the data, the AI, et cetera, everything that's in the press and the industry right now. I presume that holds true. Yes.
Oh yeah, I mean our biggest course on campus is a programming course. Second biggest course is the data science course. And the third biggest course is the next programming course. Okay, so that's kind of the heart of what most people are taking. But you never quite know what kind of foundational knowledge that you learn in college is going to be important over your whole career. We don't want to just set people up for their first job out of college. We kind of want to set them up for their 30 years after college. And so giving them a little variety of exposure to the math, lots of linear algebra, maybe a little bit of signal processing so that they understand what sensors are like and how they interact with digital systems. I think that could all be really valuable in ways that they can't anticipate. But yeah, you're totally right. So what are the biggest advanced courses? Well, the advanced data science course is the biggest upper division course on campus, followed by, I think, the algorithms course. So those are the ones that draw most students in.
And when did you say your first data science curriculum? I mean, the first grad of data science was it last year or?
No, last week.
Last week? Oh, okay.
Yeah. Well, so that's not technically true. So there were about 10 people that managed to finish in December, but we had our first commencement ceremony a week ago Sunday. And that was, the first time that there was Berkeley data science students out there in the world.
Nice. Oh, that's awesome.
It's very exciting.
So let me ask you a crazy question. So, but I think this is kind of cool. If you were to give an infomercial for the data science curriculum and the stuff that you've been doing around artificial intelligence, tell me something that I could learn in like 5 minutes here that you would say, look, here's the infomercial and here's why if you're a kid, if you're thinking about what you want to do, what you want to specialize in, this is the reason why data science would be so attractive. That's a challenge. I don't know, but off the cuff, how would that go for you?
I think that's a great question. So let me give it a shot. We'll see what happens. There's a saying that is going around among undergraduates that either you build the automated systems or you'll get replaced by the automated systems. So are you going to be one of those people that helps harness the data and kind of builds the future, or are you going to focus on something that will instead be replaced by automation? Now, I think this is too extreme. Here's another version of that. Are you going to do things the old way that didn't involve assistance by computation and computers and artificial intelligence? Or are you going to be one of those people that's extra productive because you can do them in a new way that's augmented by artificial intelligence, by computation, and by data? And the second way is where we're headed. It's already happening in lots of different fields around the world. That the way people get things done now isn't just paper and pencil. It isn't just following their intuitions. Instead, it's using data and artificial intelligence, machine learning, in order to make good decisions. But it's still the people making decisions in many cases. It's still a kind of mix of human intelligence and artificial intelligence that gets things done in the world. So when we design a data science undergraduate program, it's really about setting people up to participate in that new world, either to build the tools or to use the tools effectively, or to manage organizations that are using those tools effectively. And all this is important in order to kind of shift us toward a more computer-augmented version of the world, where people get more done, the boring stuff is handled by the computers, the interesting stuff is handled by the people. So what do you need to know in order to do that? Well, one is that you do have to understand the technology, because you want to be able to extend it yourself, tailor it to your own applications, but you also want to understand what it's good at and what it's not good at, so that you don't put too much trust into the predictions of a classifier. You have to have some awareness of when they might be wrong. If a classifier gets data that's different than anything it was exposed to at training time, it's going to do something bizarre. And if you're not aware of that and you expect it to be right all the time, then you can make bad human decisions based on problematic artificial intelligence decisions. So understanding the technology is really important. Getting some practice applying that technology is really important. So seeing that when you actually want to solve a problem in the world, it's never as simple as download the data, run some linear regression package on it, and start making predictions. There's always some data cleaning, some kind of change in representation that's necessary in order to get what you want. And so getting that experience is really important. And then the last part is really about learning the infrastructure that enables all this. So people do need to learn how to program. They need to be good software engineers, because even if you're not building a lot of software, you have to understand the tools you're working with. People need to understand the fundamentals of probability in order to reason about uncertainty and know what it means to have the chance of something happen or the likelihood of something happen. So these kind of fundamental ideas, which are like programming and probability and statistics, really build the foundation for using artificial intelligence systems and building them in the future. How'd I do? Are you gonna buy?
I think you killed it. I think, and people probably wouldn't know it. That's completely off the cuff. Yeah, nicely done. I'm in. And you also convinced me even more so. I don't know how people survive today without knowing how to program. I need to have my kids listen to you. I got one looking at pharmacy or going through pharmacy, which is all good, in law school, another one audiologist, all great stuff. But I keep saying, you need to learn how to program. Take a programming class. But they see their dad doing that and they're like, yeah, I got my own. Very good. Yeah, very nicely done. Hey, if you don't mind, I always do a lightning round, a little bit more about you. And by the way, I was going to say this at the end, but I've got to try to have you on again so we can have a part 2. There's so many more questions I got to get to. But I try to keep it so people can listen to this in their cars and doesn't go on forever. Sure. If you're interested sometime, I got to get you on a part 2. But I do want to get to the lightning round. People love the round, as I ask a little bit more personal questions about you and your makeup. If you're okay, I'd like to jump to that now.
Let's do it.
All right. Here's my first question. If you could organize a conference on a topic and invite the smartest people in your field, because I want to get this from you, being from research and all the degrees you have, who would you invite and what would that theme be?
Oh, I think we'd bring together the folks that have been working on human-computer interaction for so long with the folks who have been working on automated systems in artificial intelligence, and have them all work on the real problem, which is, how do you build augmenting systems that help people do their work, as opposed to replacing people and fully automating things? Because I think that's the future of so many different problems out there in the world. And it's the right path forward for society to kind of enable people to do better work and be more productive. And it's just an underappreciated problem. We do have some folks that are working on that in the world, myself included, about how to model people as part of the artificial intelligence problem. I love all that work, but I think there needs to be more of it.
So if you need IBM help, well, we should work together. We'll make that happen. Hey, is there anybody, I'm just curious if you're willing to say, anybody specifically that you'd want to invite, leaders out in the field that you say, oh, this 1, 2, or 3 person, they've got it. They've got to be there because I want to hear from them.
Oh, sure. So a professor here, Anka Dragan, has worked on how you make decisions when there are people involved. And she's just at the top of her game. So I'd love to have her there. For interacting with robots, another professor here is Peter Abil, and he's kind of trying to build robots that work in a home environment. So that's going to have people involved as well. The folks who work on the human-computer interaction side, Well, there's lots of wonderful people out there. The one who's been advising Lilt is named Jeff Heer. He's up at University of Washington. And he's just done a wonderful job over the course of his career of figuring out how to work with data visualization in a productive way, and now works a lot on how people could interact with artificial intelligence. So I think it'd be great to have him there too.
Great. No, those are good answers.
And sorry, I just pick academics, but
That's all right.
I live my life in university, so that's kind of that's what I know.
That's perfectly fine. You're right. Hey, speaking of academics, I know you also have a master's degree in philosophy. So why philosophy? It seemed like you were. I mean, it's interesting. You got a very wide and balanced, what I want to say, learning tree here. Why philosophy?
So when I was an undergraduate, I didn't want to just study one thing. I wanted to try everything because, why not? And I took some math. That was fun. Took some computer science. That was fun. Took some linguistics. That was really fun to understand how language works. We all speak language, but do we understand how it really works? Well, we don't. And that's kind of fascinating. And then I took a philosophy class. It just kicked my butt. I mean, the idea of pondering, what is knowledge? What does it mean to know something? Those kinds of problems. And then I did a lot of philosophy of language. So like, what does it mean for a word to refer to something? And what is that something that it refers to? These are great questions, but they're really hard. So, I mean, to be honest, like I kind of focused on philosophy because it was the thing that I had the most trouble with. It was really challenging for me. And I wanted to push myself to try to work that out. And, I didn't pull it off. I didn't become a philosopher. I have great respect for those folks. But I ended up more working on, real applied problems because that's what I have more of a knack for. But it was really fun to spend a year thinking about the really deep questions. And that's my background in philosophy.
Look, that's great, man. I mean, it's a promotion of why balance matters. I mean, that's why they say a lot of great musicians are good at math. You wouldn't think it, but I mean, it all ties back together. But it leads me to my next question. And so, when I was in electrical engineering, I had several friends going on for a PhD, and I said, "Oh, not for me, man. No way. I got mountains to climb." And then I look back now, and I think, damn, that was probably the mountain. Maybe I should have climbed that mountain because I love to learn. And as I've gotten older, I mean, I can't get enough. I mean, that's one reason why I started this podcast, because I want to learn from great people and minds like yourself. You must have recognized that very early and said, look, I love to learn. I like the academia world. I mean, how did that process go for you? I mean, it seemed like it based on all the degrees you have, et cetera. I mean, it must have been easy, but I don't know. Tell me more about it if you would.
Sure. Yeah. No, I didn't go straight into a PhD program. I got a job after school, and no one sat me down and said, "John, you need to go get a PhD." So I just figured I'd go learn how the world works for a little while. I tried my hand at management consulting, and it was really interesting. A lot of smart people, but we had 6 to 12 weeks to solve a problem. It was a really complicated problem. And, at the end of the day, we couldn't know we were right or really get to the heart of the issue in 6 to 12 weeks for any of the issues that we encountered because, consulting in the business world doesn't always give you the luxury of spending all the time you wish you could spend. Instead, you have a fixed amount. And that just didn't sit well with me. Like I'm the kind of guy who likes to spend 10 years solving a problem, not 10 days. So that made it clear to me that I should go back and get a PhD is because I wanted to just go so deep on something that I could kind of work on it until we got it right. And translation has mostly been that thing for me, and we certainly haven't gotten it right yet, but I'll just keep hacking for maybe another decade, and maybe we'll get there.
All right, I got it. That's great. So what does a day for you look like? I mean, if you were to go through your day, I got to, and one thing I'm interested in, but I don't want to give you the answer, is just, how you go about learning. Because I'm always trying to find more time in my day to learn versus solve some of the problems in the email and everything else I get. But what does a day for you look like?
Oh, I have the luxury of ignoring a lot of email. So
that's great. I wish I had that luxury.
Professors get away with that all the time. So I do a lot of teaching, and that means, thinking about what I'm going to say in lecture and writing that all out. I spend a lot of time, writing code that's like the demos that I'm going to use in a lecture. And so that means going out and reading about data sets, finding data sets, and then doing a little data analysis that I'll then present to the students. I like to do everything kind of interactively in the classroom, where I just kind of, do some data analysis, kind of live code my way through an example. But it's all scripted in advance. I always think through what I'm going to build and how to build it. And so a lot of my day goes into that kind of thing. And actually, that's how I do most of my learning, is by teaching. So, I know the topics that I want to convey, and I know something about everything I'm going to teach. But figuring out exactly how to explain something to somebody else always involves discovery. It always involves like learning new things about the subject, where you're like, oh, I think I'll say this thing that I was told once, but is that really true? Will logistic regression fit this data set in the way that I expect? Well, I'll try it. This is before a lecture starts. I'll try it out. And if it does something funky, then I have to go explore why that is. And that can turn into part of the lesson. So, so I do spend a lot of time just kind of developing educational materials or getting ready for lecture and that kind of thing. And then I spend a lot of time advising. So this is in my company life and with my graduate students. I get to listen to other people's technical problems and try to figure out enough about them to say something useful.
Are you an early riser? I mean, do you get up and you start do you start writing all this stuff out? I mean, are you kind of journal in the morning to get your head straight? Any advice you can give other of us like myself?
I got a 3-year-old at home, so I survive the mornings. I get up when he cries, and then we get him out the door fed, and then the day starts. So then, what does my workday really look like? It almost always starts with just phone conversations with a lot of different people, or personal conversations with a lot of different students. So I don't have any kind of journaling built into my life, but I do have a lot of notes from the meetings that we have together. And that's kind of a chronicle of everything that I've worked on with somebody else. And that's something that I think is really vital, is to kind of write it down, some kind of written transcript of the meetings you have when you're trying to solve problems together, so that you can not forget the good ideas that came up, and you can not forget that you already worked out that something wasn't a good idea, so you don't have to do it again later.
I got to believe you do a ton of time boxing, though, because you got these pesky students that have to come in, they want to ask questions and stuff. But for you to get, off to the next working demo code that you're working on, or the next class material that you're going to present, I got to believe there's some time that you say, look, I'm going to box like 3 hours here and nobody's going to bother me, as I'm going to get into this and get some of this stuff knocked out. Is that true or not?
Oh, that's definitely true. That's the only way I could get things done around here, is to block off, whole 2-hour chunks to try to think through something. And usually that happens kind of afternoon or the end of the day, because that's kind of my key productivity time. So mornings are used for working with other people, and the evenings are used for really figuring out what's going to happen.
Do you, particularly in data science or data, anything in technology, are there any tips or hints that you have in terms of material that you view that the common person like myself could go out there and get a ton of information from, versus wading through information and only find 1 to 2 good articles out of 20? I mean, is there anything that hits you right now that says, if I'm you, I'm going to go do X, Y, and Z? I mean, that's what you should do.
Okay, time for some self-promotion.
Okay.
We
that's what we want here. Go ahead, hit it.
We spent some time last year taking this intro data science course and turning it into an online course that anyone can take. It's called Data 8X. It's on the edX platform. And it's broken up into 3 5-week chunks. It's freshman level material. So you can be like, oh, I don't need that. But that's not true, because I learned a ton building and teaching this course by working with statisticians and other machine learning folks, even though I had already done my PhD in artificial intelligence. So there's a lot of stuff there that's kind of fundamental, how you think about uncertainty, how you think about the world, how you work with data that people just don't know, but they should. And I think I've had friends who are kind of later on in their career who decided kind of on a whim, they'll try out this online course. And they told me they got a lot out of it. Now they're my friends, so they probably wouldn't tell me it was terrible if it was terrible. But the reviews were really good, and it's structured in a way that's not going to waste your time. But it's way more than just an article. It's like a way to spend a couple hours a week for however many weeks you want to go into it. It's 15 weeks in total, but you could do the first third and then take a break for a while. And I think that people get a lot of value out of that. So you could check it out.
Nicely. Where can I get that?
Well, if you search for Data 8X, then you'll find it. But it's part of the edX platform. So edX.org does all the hosting.
All right, fantastic. We'll put that in the show notes as well. All right, I'll try to keep it to 2 more questions, even though I could go on forever. How does someone like yourself define success?
The one thing I did pick up from being a consultant, besides being pretty good with a spreadsheet, is that the way you should measure success is by your impact on the world. And not like how much someone's willing to pay you for it, but how much difference did you actually make? Like if you hadn't done this work, would it have been done anyway? Would it have been done right? And so success for me is being able to look back at my career and see that there are things that exist in the world, experiences that people have had that probably wouldn't have happened if I hadn't put my effort into it. And I think that's a general notion of success that could apply to a lot of people. And when you have that kind of success, well, I can say it feels pretty good. And it's very easy to link your efforts to the impact. And that means that you kind of know that you're doing things right.
That's great advice. So what are you most proud of then?
Oh, probably the thing I'm most proud of is something we didn't talk about at all on this show. I spent a lot of time on the intro computer science course here. And it's a cool way to learn how to program. So a lot of students have gone through it, and a lot of students have said that it's an important kind of start to their career in computer science. So that's the thing that I think I'm most proud of is my work there.
Wow. Is that also offered online or no?
That's my project for the summer, so stay tuned.
All right, so that's coming up. So I'm a little ahead of you. That's fine. That's great. So, all right, this is truly the last question. I think, I'm not promising, but I think it's the last question. So what do you work towards in your free time? I hear you got a 3-year-old, so I'm sure I know what you're doing with a lot of your free time right there. But what do you like to do for fun?
Oh, well, my favorite thing is I have an old sailboat here in the Berkeley Marina. I share it with 5 other guys from the area, but they never seem to use it, so I get to use it most of the time.
That's a perfect combination.
Yeah, floating out there on the bay and looking at all the scenery and trying not to crash is pretty fun. So that's what I do.
All right, great. I presume you don't take your 3-year-old with you yet, or do you?
Oh, I do. He loves it.
Yeah. All right, very good.
He even steers.
Very good. Any other kids?
Not just one.
Just one so far. All right. Hey, very good. Hey, John, you've been great, a fantastic guest, and I mean it when I say this. I got to get you back on because being in the data science or the data and AI field, I should say, man, there's a lot more questions, and I know that the user or the listeners are going to find great interest in this session. So I will humbly try to twist your arm at some later date when I can find some time when you have it. I would love to have you back on again.
Well, Al, it's really been a pleasure. So I'd be happy to come back on, and this is really fun. Thanks for the conversation.
Thank you so much. You're terrific. We will put a lot of the material that you went through in the show notes so people can find out more about you and more about Lilt and more about the classes, etc. I think that'll be great. But with that, I'll sign off. Thank you once again. Thank you, everybody, for listening. Let us know how we're doing as usual, and I'll talk to you next time. Thank you so much.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit IBMBigDataHub.com/podcasts to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests and do not necessarily represent the views of IBM. Until next time, over and out.